G'day everyone, so in this episode of Dingle DIY I'm going to be building some temporary stairs. Now I'm going to teach you the principles of what it takes to build a staircase. There are some basic measurements we need to find out. Those are essentially the total height and the total length, also known as the rise and the run or the going. Now with those overall measurements we can divide them up depending on how many stairs we require, and that's going to give us an individual going per step and an individual rise per step. So we have to do some estimation, some basic calculations, and we're going to figure out how many steps we need, and then we're going to exactly find out the height of each of those steps. Now the tread is going to be defined by the timber you purchase. Now there are also regulations for the staircases to meet. So in my situation, mine doesn't meet regulations because I was doing it on the cheap. I used treated pine, which is 200 by 50, and it only comes in 3-meter lengths, but I will be repurposing that timber in the garden later. Like I said, the staircase is only temporary, so I'll jump in to the calculations, show you how we do that. We'll put it all together, and at the end I'll show you how I assembled it and the handrail and things like that as well, which is pretty rough, but it's doing the job. So we'll jump into it. Okay, so the first thing we need to do is get a measurement, and that's going to be our total rise. That's from the top of your stairs to wherever the hell they're going to end up. We talk about that measurement being the rise because that's how far the staircase has to rise. Now I've got some notes here and some pictures here. Now you might think that the rise is from the ground to the top of your staircase, but you need to consider if the ground is sloping up or down, because that is going to change the height by the time your staircase gets to where it needs to get to. So this is an exaggeration of what's happening at my house. The grass and the dirt is sloping down. That's where the bottom of my staircase will end up. So I'm going to take a measurement from here to here. Then I've got to estimate where the staircase is going to end up, and then I've got to see how far out of level the soil is. So we can start off by measuring approximately how many stairs we need, and that's going to give us approximately the distance away from the house we're going to need, which will be our run, and then we can make some markings on the ground and decide how many steps we actually need, and then we'll take the rest from there. Alright, I've measured my total rise to be 2,800. Now in Australia, the regulations for an individual rise for each step, that measurement has to be between 130 and 225. So I'm going to pick a number in the middle of that, which is approximately 180. And I'm going to take my total rise, divide it by 180, and that's going to tell me how many steps I'm going to need. And then we can actually change those heights later on to suit our run, just in case. So bear with me, it'll make sense in a second. So I've just done the calculation and I've got 15.5 steps. It's closer to 16 than it is to 15.55. So obviously you can't have 0.55 of a step. So we're going to round it to the nearest whole number, which is 16. So I'm going to run with 16 steps. So now we've got 16 steps. We need to decide on what timber we want to use. And then the dimensions of that timber are going to give us the total run or the total going. So some common dimensions of timber and stairs. If you're doing a deck, if you're doing it out of 140mm decking boards, usually 2 decking boards is enough for a step, which is going to give you 280mm. It might even give you 300mm if you add the plinth as well. You can also get 190mm MGP10. I've personally gotten some 200mm sleepers because I don't plan on keeping that staircase there forever, and I can reuse those sleepers elsewhere in the garden by the time I'm done. You can also get 240 MGP10, and that pretty much covers it. So you just want to suit the dimensions of timber available to you. So in Australia, it states that your going has to be between 215mm and 355mm. Now technically the stairs I'm building aren't up to code. I know they're going to be alright, they're only at my house, so if anyone falls down them, it'll be me. So I'm not worried about that. But this is information you need to know. So with that under my belt, I know my timber's 200mm deep. I can multiply that by the amount of stairs I have, which is 16. So now I know my total run. I can plumb down from the edge where my stairs will end up, I can make a mark on the ground. I can measure from that mark on the ground 3.2 meters away, and I can check how far out of level things are. And then I can add that amount to my total rise, which I had previously, and then we can adjust the heights of our stairs later to suit. Alright, so now we've figured out we need 16 steps. I figured out the lawn slopes by 120 mil. So that's given me a total of 2920 as my total rise. And at the top here, I've just done the maths. So that new rise divided by the same amount of steps is our individual rise here, 182.5. That still lands within the tolerances between 130 and 225. Now I know the width of my timber is 200. That's not going to change. So 16 steps times 200 gives us a total run of 3200. Now, that means we're going to have 15 rises and 16 runs. So your first run is basically ground level, then your first rise all the way up, and then your last rise is here, and the final tread is basically the surface you're trying to get to, which in my case is the deck. So with the information of our total run and our total rise, we can go online, use a trigonometry calculator. With that calculator, all you need is 2 side lengths or 1 side length and 2 angles. Now we know that's a right angle, but in this situation we don't know the angles. We do know 2 side lengths. Punch it into the calculator, it's going to spit out the rest of the information, which for us is the hypotenuse, the long side, and the 2 angles. The angle at the top is our plumb cut, angle at the bottom is what we call a foot cut. So we know our stringer is going to be 43.32 long, from the long point to the long point. So we can imagine that length there to be a piece of timber all the way through here. Now that's what we call our stringer. That's what we want to make first. Once we've got that installed, we can measure down our magic number, 182.5. Measure down, put in our tread, 200, and then we come plumb down from the face of the tread. That's going to give us a line to the back of the next tread. So we can measure our 182.5 again, and then we can level that line across, and that's where we screw our tread in. Follow that process all the way till you get to the bottom, and that's basically the theory of how we would build the stairs. Now I am going the cheap way about this by using sleepers. Like I said, this is temporary and I can reuse these later. So what that means is the maximum length of a sleeper I can buy is 3 meters. And what I need ideally is 4.332. So I'm going to have to join 2 bits of timber together end to end to create my total length. So you will see me doing that. You might not necessarily have to do that if you use appropriate timber, because you can already buy those in larger lengths. So to start off, I've got my angle finder here. I'll mark my first angle, and then I can calculate the next piece I need to add on to the first piece, and that's going to give me my first stringer. Alright, our 2 stringers are in. The beam they fix to is level, and I've just put a temporary tread at the bottom. That is also now level. I was just playing around in the dirt a little bit to get it level. Now that tread is parallel with the bottoms of those stringers. You don't just screw it in level, you want to make sure it's parallel and then level the whole staircase as one. So now we're just going to smash some treads in. The treads are a given, so they're 200 wide, and we've already calculated how far in between each one for height. So now that this is assembled, you can see these blocks at the top. Those were some kind of props. They would have helped me to screw these in place without juggling a tape measure and all the other tools. So I wanted my staircase to be 1 meter wide. I put my blocks up there. That helped me screw the stringers on. I screwed the crap out of them to the beam. Now I temporarily screwed a step at the bottom. And when I say make sure it's parallel, you want the front corner of that tread right on this edge, and you want it to match over at this side. That way your stair's not twisted, and that if you do get it level, you know it's accurate when it is parallel or at a right angle to the rest of the stringers. Now one thing that's worth mentioning is the front of your stair above is in the same line as the back of the stair below, as you can see there. So every time I screwed a step in, I would make a plumb mark down, and then along this line from the top of this step, I would measure my rise, mark it, screw the next step on, so on and so forth. So this is the staircase completed. I just screwed on some vertical pieces here, excuse the birds, and then just a couple of handrails in between. They're pretty rough. As I said, this is temporary, but all you need to do is get those vertical. Your angles will pretty much be the same as your plumb cut at the top or the foot cut at the bottom. So my plumb cut at the top is the same as these plumb cuts on the hand railing. And then the vertical piece, the angle across the top of that should be the same as your foot cut. Alright, that's it for this video, guys. Thanks for watching. If you want to see more videos on this house, I am doing a video series, so subscribe. You'll see that there on my channel. And if you enjoyed this video, feel free to leave a comment. I'll get back to those. And yeah, we'll see you on the next one.